I'm here to talk about these obnoxiously large letters. At Giant Swarm, we recently did and are working through the end of a large migration from our homegrown Kubernetes cluster management system to Cluster API, which some of you might have heard of. That involved migrating a whole bunch of enterprise production clusters without downtime. I reckon that might be interesting to some other folks, so I thought I'd say a few words about it. Thanks to Regex for giving me the space to do that, and thanks to everyone else for coming to London, because it's nice to have people visit the hometown. For those of you who've not had the misfortune of meeting me, I'm Joe Salisbury. I work at Giant Swarm as VP Engineering. At some point, I'll have a good description of my job, but basically today my job is talking to you all about some of the stuff we've been up to. Hit up the link tree or scan the QR code for socials. I don't really post, and it's crap when I do, but maybe you're into that. I'm going to talk about where we started, how we made our decision to go on this journey, what the migration itself looked like, some problems we knew about, some problems we didn't know about until we got there, and then some reflection on our overall approach, our overall journey, and share some things we were forced to learn along the way. As a note, I'm going for more of a coherent story than some sort of company archaeology project. So while this might sound straightforward because the linear nature of a presentation, it really is also a multi-year journey with a ton of iteration. We're putting several years into half an hour. Let's dig into where we were at before we started this migration. For those of you who've not heard of Giant Swarm before, I'm super offended. Leave. But all these statements are true in some way. We build, operate, manage cloud-native developer platforms for enterprise. We deploy software into our customers' accounts. We take the pager. We allow platform teams to focus on differentiating work that's sort of more specific to their company. The general aim is to help platform teams be more successful in an enterprise context. And towards that, this is what our architecture. Let's get into the geeky shit. This is what our architecture very roughly looked like before the migration. It's a sort of very high-level view of our Kubernetes as a service product before the migration. You can kind of think of it as a REST API to CRUD Kubernetes clusters. You have a sort of web clients and some REST APIs at the top. The Kubernetes operators, that's the sort of core of it, and then infrastructure providers. The operators are the sort of key components here. So, for example, the AWS operator, which is probably the thing I'm going to be talking about the most, we started in February 2017, and it's so old it used TPRs before CRDs were a thing, which was a fucking nightmare. And you'd get one of these boxes installed sort of per cloud region or data center. It's sort of part of the management cluster. And if we just look at the AWS case and sort of more the data flow, you have that REST API creating a cluster custom resource, right, which describes the desired state of some cluster. The AWS operator then reconciles that CR into a set of CloudFormation stacks, and those stacks then form the actual Kubernetes clusters. And we'd have the same for our other providers using whatever CloudFormation is on Azure. I don't remember. There we go. And topologically, in terms of how this is laid out, we'd sort of set it up in a management cluster to multiple workload clusters set up. So the management clusters are responsible for managing the infrastructure, and then the workload clusters are where your actual customer workloads or deployments are run. And we'd have one MC per cloud region or data center per customer, right? And then we're sort of taking care of all these management clusters. And there's no sort of shared infrastructure between management clusters or customers. That's enough about Giant Swarm. Let's move to Cluster API. This is I'm about to say this is the earliest reference Marcus could find in our Slack to Cluster API. If you search Cluster and API in a technical Slack, it's a nightmare. And this was a bit after it was getting kicked off. This sort of second quote, you can see one of the sort of keps beforehand. None of these links work anymore. But you can see the push around having a declarative API for cluster management. And to dig in, Cluster API also started in 2017. It's now a fully fledged Kubernetes subproject around having declarative APIs or custom resource definitions and tooling for managing Kubernetes clusters, right? Users include, well, us, but other companies like Red Hat, Azure, I think Mercedes and Twilio and stuff. And the idea is to have Kubernetes operators to manage Kubernetes clusters, which sounds familiar. See, there's foreshadowing. I've stolen this from the Cluster API documentation, and it sort of shows the architecture briefly. So you've got the controllers to the left. They sort of support more infrastructure providers and different ways to provision Kubernetes, so they sort of split out the behavior a lot. You've got custom resources to the top right and providers to the bottom right. I'm not going to go into detail on specific controllers and custom resources. I'd recommend finding a Cluster API deep dive talk from people who actually know what they're talking about. But there's some notable similarities in the overall design, right? You stick a custom resource in and you get a Kubernetes cluster out, but there are some notable differences, right? I can use my laser pointer, BAP. Cluster API has a sort of shared controller that we didn't have, and they've sort of also used different bootstrap providers as a separate operator, where we had like a shared library in Giant Swarm. There's a few things like that. Topologically, it's a similar layout. This is one management cluster. You then have a number of workload clusters. And they're already supporting, at this point, sort of a more flexible topology around providers, whereas we had a sort of one-to-one relationship. And yeah, at a certain point, we realized we were somehow building the same thing, or at least building towards the same thing. There's a shared basic set of features, and some features in Cluster API we'd like to have, and some features we knew we'd have to add. At the very least, there's some isomorphism between the two systems. I couldn't get the joke onto the slides, but that whole thing about like all crustaceans eventually become crabs body plans, it's like all cluster management systems probably evolve into something that looks like Cluster API. There we go. I'm just using a single train emoji because I couldn't find a way to describe the whole bunch of internal discussion that I'm going to really hand wave over. But eventually we got to a point where we were in the understanding that Cluster API would probably be a better way forwards than building our own internal controllers. The major benefits we were looking for were not having to spend as much time developing our own controllers, right? Like maintenance around new Kubernetes releases was quite onerous. There was definitely some features in Cluster API we wanted to take advantage of, and with new providers, we definitely wanted to be able to sort of use the community there. We previously reckoned it would take one team around 6 months to sort of build out a provider, which is just a heavy investment. That was something we're trying to improve. So yeah, let's talk about the actual work of getting from our custom controllers to Cluster API. Just for some jargon, because otherwise I'll confuse everyone. We ended up naming the old legacy system Vintage. I wasn't in the meeting. The new Cluster API product is CAPI or Cluster API. Creative, names are hard. So there's an old system and the new system. The old system is Vintage, not legacy. It's a nicer name. The new one is Cluster API or CAPI. So I'll say Vintage, translate legacy. It's just too ingrained in my brain at this point. We were running on 3 providers, so AWS, Azure, and KVM. Hopefully, AWS and Azure are obvious what that means. KVM was a custom bare metal solution that used KVM for like nested virtualization in Kubernetes. It's another talk, ignore it. Think bare metal. And CAPI has multiple providers, so the naming pattern is sort of CAPX is Cluster API for X. So Cluster API for AWS, Azure, and vSphere, I've checked my notes here, and VMware Cloud Director, which is a different virtualization product. I got it right? Which I learned about while we were doing this. We decided pretty early on that we'd have to perform a managed migration for AWS. For us, it was a large number of clusters, and we want to provide as much value to our customer platform teams as we can practically or pragmatically. And also as a smaller team, prolonging the time we'd have to maintain both systems would be painful. We had a breaking change on Vintage in late 2019 that required customers to move clusters, and it was just painful for everyone involved. For Azure and KVM, we actually opted to not perform a managed migration. There's a smaller number of clusters there. Sorry, Microsoft. Some customers were on and offboarding, and we reckon it just wasn't worth the investment, especially with moving from the sort of nested virtualization to vSphere is just a project I wouldn't want to be on personally. So the live migration part covers AWS only. I'll sort of implicitly talk about AWS from now on. With the other providers, we built them out as part of the new product line. And new customers would create those clusters. Old customers, we had to sort of handle them with a sort of manual migration. This is a fun organizational quirk. Timo, this is your slide. Early on in the journey, we organized what we called a hive sprint, which is very on-the-nose naming, I know, for Giant Swarm, but names are hard. The aim was to get the whole company to understand, try out, and ideally implement the migration from Vintage to Cluster API. So we actually just took a month, suspended our usual teams and meetings, self-organized new teams, and hacked on Cluster API. We didn't manage to do the migration in a month. It took a little longer, but it did work well for some other reasons. We got the whole organization to understand the future direction. People got in touch and tried things out with Cluster API, and we managed to sort of iterate on blockers and issues quite quickly. And it kickstarted a lot of the larger decisions that we sort of then followed up with in the following period. And yeah, sort of coming out of that, we found Cluster API wasn't a 100% fit as a replacement, right? And to some degree, why would it be? We also found that different Cluster API providers had different levels of maturity, like they're essentially different projects, and then sort of required different levels of investment. This is one of our many GitHub issues tracking various work, because a lot of the time between the sort of Hive sprint and now was spent on product development, which I think interestingly is various pieces of work. There wasn't any sort of single horrendous bug fix or major feature. It looked more like stability and security and enterprise requirements, right? And I quite like this actually as a good example of how open source projects actually get built. It's multiple parties working together, and it's that hard work of you have 1,000 small features and bug fixes to ship and upstream. Because yeah, if you're adopting open source projects, they won't get where you need them to be if you're not putting in the work upstream, to be blunt. As a fun problem, if you work for HashiCorp, you legally have to leave the room before this part of the talk. We built support in Vintage for using HashiCorp Vault. It's like a secret store for PKI and sort of certificate management. So the AWS operator would indirectly talk to Vault to issue certificates and then distribute them to worker nodes with Ignition. Because we're using Flatcar, thanks Kinfolk. And we'd then use a sort of separate PKI route for each workload cluster because it's like nice for security. When we migrate, we need to have the same certificate route, otherwise things get super fucking hairy. I tried not to swear in this one, I did that there. We knew we'd be using kubeadm for provisioning the Kubernetes clusters, and with kubeadm you can give it a CA cert and a CA key, and that works and it's all fine. The fun fact is with Vault, it won't give up the root CA signing key. It's part of their security model that you only get the root CA cert. So what we ended up doing was forking and patching Vault, so we have a insecure version of Vault that will give you the root CA signing key. So at the start of the migration, we moved to our hack version, and we can then use that to put all the certificate material out. It's a sketchy thing we did. For the actual work of the migration, we decided not to mix Vintage and Cappy in the same management cluster. It's more straightforward with like Kubernetes API versioning. And in the Hive sprint, we manually proved you could migrate, and we started building that out into a CLI tool, which we creatively called API Migration CLI names. And at a very high level, you can understand the migration as moving the workload cluster from the Vintage management cluster to the Cluster API management cluster and transforming it from one to the other sort of during that. Because people asked, we did have some other approaches we sort of discussed for handling the migration. The CLI was what we ended up doing. We also discussed having a sort of operator solution to more automatically handle this, and some ideas around sort of like a blue-green Kubernetes cluster solution. The CLI is what we ended up with. It's practical for our number of clusters, right? It's in the hundreds, right? It's doable. And the development is very straightforward. If we did end up doing thousands or tens of thousands of clusters, we would have done the operator, but we reckon it would require more development work for a sort of fully automated solution. And the sort of blue-green option was the least explored. A lot of our customers have really limited IP network space, so sort of doubling up a cluster for the migration just isn't practical for them because enterprise is a nightmare. And for the actual migration process, I found it best to discuss the migration in two parts. This first part relates to the migration of custom resources and that management, and the second part relates to the sort of the infrastructure and the management of nodes. So our CLI takes care of all of this, but what we're essentially doing is fetching all the cluster custom resources from the Vintage management cluster. So those are the sort of CRs that represent the infrastructure. And then we'll use our hacked Vault to migrate the secrets from Vault into the CAPI management cluster. We'd have switched that beforehand, and we'll then stop reconciliation of the old controllers. We have a pause annotation, and it's so that the old controllers don't try to sort of start migrating back, right? You have one hand on the wheel. And what we do then is the API Migration CLI has logic to translate from vintage custom resource to Cluster API management, Cluster API custom resources, and it will then apply those to the Cluster API management cluster. And if you then look at it in terms of, this is a horrible slide, I'm so sorry. If you then look at it in terms of nodes or the infrastructure, the Cluster API workload cluster starts coming up, and this is where the actual migration happens. I'll break it down by etcd and the control plane and workers, because this is a complicated thing otherwise. etcd is probably the most interesting part, or the most complicated part, because it's etcd and it's kind of the core of the cluster. What you actually end up having is we start off with Quorum with a sort of HA etcd cluster from vintage. One cluster, you sort of read it left to right, yeah? One Cluster API control plane node will start, it joins the cluster, and amusingly, Cluster API's etcd management will then kick out the unknown vintage members. One of the engineers referred to this as a virus, and I kind of like that analogy. And then once it's kicked out the other two members, then as the next two Cluster API control plane nodes come up, they join the cluster and you've fully replaced it. The control plane and the workers somehow are symmetrical. We start off with the vintage control plane. The CLI tool is actually adding the CAPI control plane nodes to the vintage ELB as they become ready sort of throughout. So we always have healthy targets. But essentially as the Cluster API control plane comes up, it's talking to the same etcd cluster, the API server is stateless otherwise. Once that comes up, we stop the control plane components on the vintage nodes and then cordon, drain, delete. And with the workers, once new workers have come up, we then start for each node pool, cordoning, draining, deleting. And it's a ship of Theseus vibe, right? Like if you replace all the planks in the boat, you have a new boat. That's my philosophy anyway. And yeah, this is the most important thing I want to share. Churros time is a really important time of the day. At this point, we've ended up with the workload cluster entirely replaced and managed by Cluster API, so somehow mission accomplished. And I think it's interesting that if you exclude the special cases, right, so Vault generating the new Cluster API resources or migrating the management cluster, it somehow looks a lot like a regular Kubernetes upgrade, right? You replace the control plane, you replace the workers, you've upgraded. As a note for the networking of the clusters, we actually sort of preserve the VPCs and DNS before and after. Those aren't affected here. Cluster API or Cluster API for AWS has features to support that, and our aim is then, like with VPCs and DNS, to sort of slowly migrate that over time in less customer impacting ways. And these are the commits over time for the migration CLI tool. The first few migrations obviously exposed issues, and we also found we'd encounter new issues every time we migrated a new customer. Or in the other way, there are some clusters that are just gigantic, and we found issues there. It's a whole other talk to go through the bugs, but if you're interested, there was one bug where we ended up with different default node siders. So we were like using a /25 in vintage and then accidentally a /24 in Cluster API, which led to pods having the same IP address, which is a nightmare when that happens. We had one customer who'd manually done changes to root tables in their AWS account. So when we migrated, it didn't know where the root tables were. And we also doing migrations in AWS China. And if you've done stuff in AWS China, things are just weird there. But yeah, with the CLI approach, sorry, if I hit this, it's an awful sound, isn't it? With the CLI approach, it just requires the lead work, right? We started with a nice customer, not our non-nice customer. And you can take an iterative approach with these things. And with the actual migration done for one cluster, in a repeatable fashion, the job becomes customer management, and our account engineers do a hell of a good work here. Because there is actually a fair degree of customer management, especially with enterprise, right? You have change freezes, you have stakeholder management. With one enterprise customer, they wanted a video call for every migration, and they have hundreds of clusters. But after migrating several together, they gained enough trust that they only joined in for high-level environments, production. It becomes a lot easier. And I don't have any wood here. I will knock on wood later, but we achieved all the migrations to date with no data loss and wording, no major production customer workload impact, because dev clusters did get a bit hairy. And yeah, this is the schedule for next week. I don't know which clusters. I don't think I will talk about customers. That's not a good idea. So yeah, let's talk about some reflection. This is the retrospective side of this. Yeah, there's just a lot of emoji slides. I'm sorry, I'm not good at slide design. I think one thing we learned was you're always going to be juggling more than one migration. This was not the only migration we were doing over time. You can't stop the world and just do this one thing. So, for example, we ended up replacing our custom SSH access solution with Teleport, or we moved from that REST API to a sort of Kubernetes API solution with SSO, and we built GitOps support. And there's all the rest of the development we did over 5 years. And I think with my engineering hat on, you'd love to be able to do one thing at a time, but realistically, at any thing apart from a small scale, it's just not feasible, right? So we sort of ended up sort of embracing the juggling, which is a phrase, don't like that as a phrase. And we were also initially worried that using an upstream solution would slow our pace of development and then sort of lead to customer frustration. I think that's because we ended up doing bad things with our custom built solution, right? We were very happy throwing out a hack quickly to make a customer happy. But we ended up having a really positive reaction from using a fully upstream solution, right? I think the upstream actually makes their decisions with more consensus, there's more use cases, it's a more flexible architecture. It's that sort of get it right to go fast vibe. And I think we'll end up actually also thinking more upstream across the company, which is quite nice. And interestingly, upstream's kind of turned out to be a source of authority with our customers. Like if we tell our customers, this is what we understand upstream's ideas and their direction, they take that as written, and it's actually quite powerful argumentation for us. With team topologies, at a company level, we had a balance between sort of keeping existing customers happy and working on the new system, right? If you start reading like Mythical Man Month, Second System Effect, that's some sort of stuff here. To begin with, we had one team working on both Vintage and Cluster API. It kind of worked to begin with when Cluster API was a lower priority, but given the degree of work and customer support for Vintage, with both priorities in the team, we ended up just not developing Cluster API as much as we wanted. So we ended up splitting the teams. We had one team working on Vintage in more of a maintenance mode and building that capstone release to launch the migration from, and the other team with the primary priority to sort of get Cluster API to production or migration ready state and sort of land the migration. And that's when development really started taking off. We did also start using CapG, so Google Cloud, and Capo OpenStack while we were quite early in this journey, so sort of building out that product line. We had some customer interest in these providers. We definitely learned a lot from Cluster API, or sort of about how to manage new providers. It was definitely tough and distracted from the migration, or sort of building out those other products. I think my learning here is like trying to reap the benefits of a migration before it's done, right? We weren't really there to use it sort of at that point. But we've definitely gotten to a point now where new providers aren't particularly scary. 5 minutes, oof. So we're definitely a lot further with integrating Cluster API into our product, as well as supporting and bringing up new providers. For some reason, people aren't as keen on VMware for some reason lately. It's an easy joke, that one. So, for example, with Proxmox and Nutanix, we're investigating the new providers. We don't think it's actually going to be that painful to bring up. It's definitely not going to be a one team for 6 months, which is the big benefit there. And I think one of the most interesting questions, or for me personally, has been when to replace a custom-built solution with open source. I think very often you can choose an open source project and it'll do exactly what you need it to do, right? You're not going to have to push a PR to Node Exporter for it to do what you want, because it's feature complete, not shading on Node Exporter. But some of the time, especially with more complex requirements, the project is close but won't match 100%. The project will develop and mature, but it's not going to eventually magically add your requirements, and you need to do some degree of the work, but when do you do that work, right? And I think I'd actually reframe the question more as, is your solution custom or differentiating to customers, and will it differentiate in the future? So I'm going to very quickly throw up big graphs. This is a Wardley map. It's a tool for describing value chains. The y-axis represents how visible something is to a user, and the x-axis sort of represents commoditization. At Giant Swarm, we want to provide internal developer platforms that has requirements like Kubernetes management, Kubernetes clusters, and compute and stuff like this. And these things are all commoditizing over time, right? Like, compute is now a commodity. And for example, with Kubernetes clusters, we've seen them move from custom built into more of a product to where I would argue they're more of a commodity now. And I think as a component becomes more commoditized, your methods change, right? You're sort of moving from agile into more, you can actually build a community around it together, right? You're going to have a group of people with requirements, and I think that's the inflection point where to replace a homemade component with an open source component, right? Where you actually can have multiple organizations working on it together. And then, as individual companies, we still want to be competitive. We can move up the stack, right? Or in another way, your company has a limited number of innovation tokens. Don't spend them on things where you can work together with people. Spend them on the things that differentiate you. It's theory, I don't know. Here's a super scary looking diagram. I will not go off into this. I'm not going to explain connectware. But this is, for example, our newer hybrid smart factory industrial IoT platform. This currently is working at producing 1/3 of all the toilet paper in Europe. Fun fact. But we run a management cluster in the cloud and worker clusters in factories on VMware and stuff like this. And this is what we've been able to start doing since migrating to Cluster API. We're building on functionality on top because we're managing to make use of that open source product where we're all collaborating and sort of building on top. Don't take photos of this. It's not good. Yeah, and I'll start finishing off. This is a bunch of really attractive people. One theme I had because I had to talk to a bunch of people in the company to prepare this talk. Everyone noted that it was very much a team effort from the whole company. So this is me saying thanks to everyone who pushed this effort in any way. I wouldn't be able to talk about this and pretend I did all this work if they hadn't actually done the real engineering. This is us in Morocco. It was lovely. So yeah, that's all. I think I'm in time. Thank you very much. If you're on a platform team and want to do less of this, talk to me. Thank you very much.
We have time for maybe 2 questions.
Oh, fuck. Yes.
Sorry, you rushed too much. All right.
I've taken the slides off, so if I have to reference something, I'm dead.
Hello, thank you for the talk. I wanted to ask, what concerns, especially the technical ones, do customers see when migrating? Because I can imagine that they are scared of the unknown, they are maybe scared of the complexity, but is there something valid, maybe technical from your perspective?
I mean, it is a fairly intensive procedure for a cluster, let's put it like that. I think you end up sort of into a customer management stance, right? We have a lot of preparation there in terms of explaining to them what's going on, and we would all, with some customers, we start new clusters and then show them the migration on that, so it's not even close to a production, and then we'll work from low environments to high, right? We know it works, customers don't know it works, and that's very valid. So, we start off with tests, making sure they really understand the solution, and then sort of work upwards from that, yeah. We have a long-term relationship with most of our customers, so they generally kind of go, okay, we'll work through this together and go from there. Yeah.
Right. Thank you. Once again, thank you to Joe.